parametrically polymorphic functions, what are they? Well, what is a parametrically polymorphic function? It's a bit of a mouthful to say, but essentially it's a function that can work with parameters of different data types. So it's a function which is polymorphic based on its parameters. And I'll explain what that means, don't worry. First off, let's have a look at function type definitions. So a function type is a mapping from an input type to an output type. And that should make sense because a function itself is a mapping from an input value to an output value. So the type of that function makes sense to mean the mapping from the input type to the output type. Let's have a look at an example, okay? So this is the add function. This is the type definition, right? What add does is it takes a pair of ints and it returns another int. So this is the type definition. This is the function definition where you actually take that pair of ints x and y and you do the result, which is x plus y. And here's an example. So 5 plus 3, if we do that, it gives us 8. And if we replace this to like 9 or something, then it does 12, which is what we expect. Okay, polymorphic functions. So first, I've got some examples. So in order to better understand, I'll show you the examples of polymorphic functions. The first one being id, right? What id does, this is an example. If we do id of 5, we get 5, okay? And if we do id of Fraser, we get Fraser. So what does id do? It just returns the value which was inputted with no change. And the reason this is polymorphic, right, is because it works on line 23 for an integer and it works on line 30 for a string. Therefore, no matter on what the type is of the function, no matter on what the type that the parameter of the function is, it still works. And that's what the whole idea of being parametrically polymorphic is. It means that it doesn't matter what the data type of the parameter is, or the input value, the function still works. And in this case, because the function, all it does is it returns the value that you give it, then yes, of course it can work. So for completeness, here's the definition, and you'll see this thing. So I've got this A thing. What does this A mean? This basically could be of any type. It's of type A. A could be an int, A could be a string, A could be a list, it could be anything. And then obviously this is the definition of the function. You know, it takes an x and then it returns an x. That's all it does. And then you can see the definition, the type definition. It takes any type and it returns something of that same type. So you can see the A here and the A here. And what this means is that this A here has to be the same type of the first A. Otherwise you can put things like A, B, C, and you can use whatever letters you want, sort of thing. Let's have a look at another one. This is called head. This head function, it takes a list in the first example. Let's see what it does. It returns the first item of the list, which is 1. And then here we go, we've got now a string. Let's see what this does. It returns the first item of the string. So what head does is it returns the first item of a list. And obviously because a string is just a list of characters, it treats it as a list of characters, which means the first item of that list of characters is capital F. Let's have another look at the definition for this one as well. So this is the type definition again, and you can see now it takes a list of type A and it returns something of type A. So as you can see on line 44, it takes a list of integers, and then on 48 it returns an integer. And then on 51 it takes a list of characters, i.e. a string, and returns a character on 55. So that's what it does. Now for a final example, we'll do first. Now this is an example where you can use more than one thing. So you have of type A and type B. So what this is essentially saying is we take a pair, and this pair, you know, it can, the first item in the pair and the second item in the pair, they can have different data types, and it will only return the first item. So I'll write a quick example. So if I do like first of I don't know, 2 and 4 or 2 and 3, and I run that, I get 2. But if I say, you know, hello, and I run that again, it says hello. So that's what this does, right? And you can see, you know, A and B can be the same in this example, right? A and B are the same data type, but they don't have to be the same as in this example. And actually, I'll show you one more bonus example. I'll call this maybe like swap. Yeah. And what swap will do, right, is it will demonstrate that you can use A and B in both inputs and outputs. So I'll show you. So A, B, and this time it will return another pair of type BA. And the definition for this would be like you take X and Y, right? And what you want to do is you want to swap the positions of X and Y. So that's very simple to do. You just do Y and X. That's all you need to do. I don't know if this swap variable, this swap function is like a standard function or not, but this is what I'm going to call it, right? Swap. There may be a standard function which is the same functionality. So if I run this code snippet, obviously it produces no results, right? Because it's not done anything, but it's defined the function. Now if I do swap of, you know, I don't know, hello and 5, and I run that, it gives me 5 and hello, right? That's the swapped version. But of course, you know, they don't have to be different data types. This could be like hello, you know, Fraser, and now it will swap it to Fraser hello. So essentially the point of this video, right, is to explain what parametric polymorphism is. And the key takeaway for you could be that all parametric polymorphism is the fact that if a function is parametrically polymorphic, then it will work with different data types for its parameters, such as, you know, the swap, that works with different data types. You know, I've just shown it here, it works with different data types. You know, if I go to the top, you know, add, this isn't parametrically polymorphic because in here I specify there's ints, right? So this isn't parametrically polymorphic. But ID, right, ID is parametrically polymorphic because it can take an integer and it can take a string however it wants. So that's good. And then obviously first is parametrically polymorphic because, as I've shown before, you know, I could replace this with, instead of an integer, I could replace this with, you know, another thing, like another string, and it will still return the same result because all it does, it takes the first one. But the point of this is that if something is parametrically polymorphic, its parameters, the data types of them, don't matter, the function will still work. Another example of this off the top of my head would be a length function, right? Where you find the length of a list. It doesn't matter what the data types of the values in the list is because all you're going to be doing is counting how many things are in the list. It doesn't matter what type of thing that thing is. So yeah, I hope you've enjoyed this video and I hope it's been helpful. Please watch my other videos, like and subscribe. If you've got any questions, let me know.